Welcome our channel Learn Classes. Today we start with the mechanical most important questions. Now we start. Real fluid always follows Newton's law of viscosity. Newton's law of viscosity. The real fluid follows the Newton's law of viscosity. The energy stored in a flywheel is equal to I omega square Cs, where C is the coefficient of speed. I is the moment of inertia, and omega is angular velocity in radian per second. Energy stored in a flywheel is also equal to half I omega square is equal to, and so the energy stored in a flywheel is equal to I omega square Cs, where Cs is the coefficient of speed and omega is the angular velocity in a radian per second. I is the moment of inertia. Energy is two formulas, and the other formula is energy stored in a flywheel is half into I omega square. What is angular speed? What is the angular speed? Commonly, angular speed is denoted by omega. Commonly, the angular speed denoted by omega. Omega is equal to 2 pi n by 60, where n is RPM, revolution per minute. So can dividing by 60, then we are taken angular speed as revolution per second, minute converted into seconds by dividing 1 by 60. So its angular speed denoted by omega, and formula is omega is equal to 2 pi n by 60. in gear, circular pitch, PC, circular pitch is equal to pi d by t. D is the diameter of gear, T is the number of teeth. Diametrically pitch is equal to T by D. T is number of teeth and D is diameter of gear. The value of PC into multiply by PD is pi d by t into t by d. So it's cross and pi. This is the most important. The value of multiply pen circular pitch with the diametrical pitch is pi. What is the module of the gear? Module is noted by M and module is equal to d by t. D is diameter of the gear and t is the number of teeth. In IC engine, when the temperature of the engine increased beyond the limits, what happened? What's happened? When temperature of the IC engine is increased, then output is decreased. In IC engine, when temperature of the engine increased beyond the limits, then with increase of the temperature, output of the engine decreased. Cutting ratio of the cutting tool. cutting ratio is denoted by R and is equal to T DOC by T cut. DOC is the depth of cut. T is the cut, and the ratio of cutting ratio is always depth of cut by T cut. It is taken into commonly taken into mm, and T cut is also taken into m. So that cutting ratio of the cutting tool is denoted by R and the formula of T DOC by T cut. Chip sliding velocity. Chip sliding velocity denoted by Bs, and formula is equal to B sin phi y cos phi minus alpha. When the rack angle increased, what factor what factors affecting the increase with the rack angle, cutting speed increase with same forces acting, keenness of the tool increased, keenness of the tool increased, heat generation during the cutting process decreased, during cutting process decrease. Strength of the cutting tool decrease, strength of tool decrease. So with the increase of the rake angle in the cutting tool, cutting speed increase its positive point, and keenness increase its positive point. So the cutting forces decrease, heat generation in the process decrease its positive point, and strength of the tool decrease its negative point. With the rake angle increase, that are the factor affecting chip reduction coefficient. Chip reduction coefficient is the reciprocal of the cutting ratio. Is equal to 1 by R. R is equal to T DOC by T cut. T DOC is the depth of cut and T is the actual cut. Commonly T cut is taken equal to feed. Commonly the T cut is taken is equal to feed with this process. T cut is equal to feed of the tool. The efficiency of the process increased. So, for increasing the maximum efficiency, we taken T cut is equal to feed of tool. With taper turning attachment, we achieve only external tapers on the job. With the taper turning attachment, we obtain only external taper. Only we obtain external taper. The internal tapering not achieved. In the lathe machine, the turret is mounted on the saw tram. That is sliding on the saddle. In lathe machine, turret is mounted on the saw tram that is sliding on the saddle. Least count of the vernier caliper is equal to 0.1 0.05, 0.02. Commonly used least count is 0.02. Least count of the micrometer is equal to 0.01 mm. Least count of the metric micrometer is equal to 0.001 mm. Note, in the micrometer least count 0.01 and in the metric micrometer least count is 0.001 mm. Least count of the metric vernier caliper is equal to 0.001 mm. Least count of the micrometer is equal to pitch of screw divided by number of divisions on the thimble. Generally, pitch of the screw is 0.5 and the number of divisions on the thimble over 50, and least count of micrometer is 0.01 mm. So that's all.